for coming. What I'm presenting today is basically one of the 3 chapters of my PhD defense. It was a collection actually of quite heterogeneous pieces, but okay, the presentation of today is gonna talk about the effect of Facebook discussions on academic performance. So it's a joint paper with Paolo Pellizzari from the Department of Economics here in Ca' Foscari. So first of all, the motivation for this research. So basically nowadays, more and more we see that people are using smartphones and tablets all the time. So basically they are always connected to the internet through different devices, which is good and bad, let's see. And so actually a lot of tools have been developed, such as social networks and online platforms. And all of these forms of technology-driven tools, let's say, are also entering somehow education. So more and more traditional teaching methods are being combined with some form of technology-driven tool to support education. So you have different examples. For example, one of the popular one is called MOOCs. You probably heard about them. So this stands for Massive Open Online Courses. So these are basically just courses that are entirely taught on the web. They are freely available and potentially open to a very large number of potential users. Then there is a different kind of tool, which is called blended learning, which basically combines 2 different methods. So on one hand, simply face-to-face traditional teaching, but on the other hand, it puts it together with some sort of not exactly defined technology-driven tool, like a social network, an e-learning platform, or something like this. So basically what we are going to see today is an empirical paper. So it will be basically we will be basically seeing data analysis in the field, as I told you, of economics of education. So what's the story here? We study the effect of a social network on academic performance. So what do I mean by this? Basically, a few years ago, an experiment took place in one of the mathematics courses for undergraduate students of economics in a large public Italian university, which is Ca' Foscari. So the story is basically that this professor activated and opened a Facebook page where students could ask questions about the course, and they would get answers both from the other students and from the professor. So students could interact among each other on the platform, and the professor was also checking answers and writing on this Facebook page. So basically, the research question of this paper is quite simple. So we are interested in checking if availability of this Facebook page helped students in increasing their performance. So basically increasing their performance, I simply mean we want to see if activity on this Facebook page increased the grades that students achieved in the mathematics exam. So we will be looking at 2 things: the effect on the mathematics grades and, in a different specification, the probability of passing the math exam. So did availability of this Facebook page increase the probability of passing the exam? So how do we set up the study? Basically, we implement what is called a quasi-experimental design. I will just in a second tell you maybe better what this is. And basically compare the performance of students who took the math exam with availability of the Facebook page, and compare it with the performance of students who took the math exam without availability of this Facebook page. So it's a quasi-experimental design. What does this mean? So basically now, of course, we are interested in looking for, we are always interested in trying to look for causal effects. And nowadays, especially in this field, it's very common to have what you ideally would want to have is a randomized experiment. So you have 100 students, you want to study the effect of something, you sample randomly 50 students, you give them a treatment, which in this case is Facebook, and then compare the performance of students that had and did not have the treatment. We do not have this because we cannot randomize students who get and do not get Facebook, but we are able to use a setup in which there is a group of students that get the treatment and a group of students that does not get the treatment, taking advantage of the fact that the same mathematics course was held for undergraduate students of economics in the same university, but in another branch of the university. So, you know, I will go into all of the details shortly, but
without this random factor, you will find the risk that maybe those who are using Facebook, they already smart on their own.
Yes, of course. So this is the...
Why this idea of randomizing the sample, in some sense, is able to account for this. Right?
Exactly, yes. So of course it... Yes, of course, of course. And so ideally, of course, we would like to have a randomized experiment. We do not have it. So what we need to do is we have to take all the caution that we can. So do all the checks possible that can help me to be convinced that we are comparing two similar samples, and then, I mean, convince you. So of course I agree that the main point to claim causality is we want to be as sure as possible that we are comparing two similar samples, and I will show you some statistics trying to go into this direction. So, okay, what do we do? Basically, we compute difference in difference estimates. We will go into the specification shortly. And what we find, so the main result, okay, so the main result, so what you need to grasp is that basically students who took the math exam in the town where the Facebook page was available, actually what we find is that they gain approximately 1 additional point out of 30, and the difference is statistically significant. So we can discuss later. It's not big, it's not, maybe not very small, but anyway, it's 1 point out of 30, actually less, because from 18 to 30, and sorry, it is statistically significant. The other thing we do is we work also just on the treated students, so the ones who took the math exam in the town where Facebook was available, and we try to understand if students perform differently according to the different attitudes they were having towards the page. So we will see later what this means. So students trying to understand if students who use the page more performed better, and so on. Okay, so we can go briefly on this. So basically the idea was that students often use Facebook when they are studying. So, I mean, I do it myself, a lot of students do it. Perhaps they are studying, but they have different windows open on the browser. They're checking some stuff, and then they go to Facebook, waste some time, go back studying, and so on. So the idea was basically to try to take this into account, and in a way try to use the social network, but in a positive way. So trying to take into account the fact that students often anyway waste time on Facebook when they are studying. So basically the key contribution, as I told you, is to study the effect of availability of this Facebook page, but differently from other studies, it's when this Facebook page is specifically designed as a tool to support education. So again, just to summarize, we use a quantitative approach to measure the effect of availability of this Facebook page when it is a tool specifically designed to support education. So there are a lot of other tools such as Moodle or other e-learning platforms that technically are able to provide the same type of information. So you have a forum, you can post material and so on. So technically they are able to provide the same information, but the idea here was that what it seemed was actually that using a Facebook page, it was kind of more, students liked it more, they found it more friendly, they knew how to use it more, so perhaps they got more engaged on the page. So a few details about the page. So as I told you, it was activated and administered by the professor, basically for two reasons. So the first one was, it was simply a tool that was useful to provide information on practical aspects of the course. So it's a math course, it's an introductory one of the first year, so you have to think it's a super crowded course with a lot of students. So some of the information you could find on the page was simply, I don't know, which was the timetable of the lectures, changes in the office hours, changes in the schedule, the classroom, so just administrative, technical information. But the second one, the second purpose, which is maybe the one that is more interesting for our purposes, was that it gave students an additional channel that they could use to communicate both among each other and with the professor, to ask questions on exercises that were not clear during the course. I wasn't able to solve this exercise, can you help me? I didn't understand this part of the lecture, whatever. So the idea was also that perhaps you are also a smart student, a good one, but you are shy. So in a big class, you do not want to raise your hand. Like I was also never asking questions. You don't want to raise your hand in front of a big class and ask a question, maybe because you're afraid it's stupid or blah, blah. But if you can just post your doubt on the wall of the Facebook page, then this can be useful for you and potentially also for other students that had the same doubt. Okay, so this is very small. I guess you cannot see it very well, but just to give you an idea, I have 3 different screenshots of just to show you the type of activity that was going on the page. So here on the left, you see the professor. He's basically just explaining how to compute the derivative of a product. So somebody had a doubt, he just writes the expression and tells the students how to compute the derivative of the function. In the middle, you have a student saying that he skipped the class, so he missed a lesson. And as you can see, another student is actually taking a picture of his notes and posting it on the Facebook page, so the student can see how to compute the dominium of a function or whatever. On the right, it's a student instead proposing to organize a group to study together and do some exercises for the course. Volevo proporre una cosa che andrebbe ad incontrarsi in un gruppo giovedì dopo la lezione per fare degli esercizi. So just to give you an idea about the type of information that was flowing on the page. So in a very short amount of time, actually a large number of posts were coming up on the page. Just a few things about the course before going to the specifications. So basically it's a super standard first year introductory math course for undergraduate students in economics. So topics were linear algebra, some introduction to easy financial discounting, matrices, and simple stuff like that. So standard introductory math for economics students. So students met with the professor 3 times per week for 1 hour and a half during an entire semester. So it's the first semester, so from September to December. The exams were, actually there was the possibility to take a midterm, so splitting the exam in half, 1 in November and 1 in December. But the formal sessions were twice in January, once in June, and once in September. So actually this experiment was held 2 subsequent years, one in 2011 and one in 2012. So during the course and before the exam took place, both years a survey was filled out by students on a voluntary basis. So okay, the voluntary basis is the fundamental thing, we can discuss about it right now. So actually students filled in a survey where actually the professor wanted to understand if students were active on the page, which was the level of engagement of students on the page, if they found it useful, how much they thought they would gain thanks to this page, and so on. So the sample is actually made of 217 surveys in the first year and 138 in the second year. Okay, so of course, this was the first data we collected, and before I jumped into the project, he was planning to do an analysis just with this data. But of course, okay, or maybe not of course, or okay, whatever, it's maybe not the best way to go, because these surveys were filled in on a voluntary basis. What does this mean? Okay, it's maybe the case that if you are a student who likes math, or if you are a student that is more engaged on Facebook, you fill in the survey. While if you are a bad student, you don't like Facebook or you don't like math, you don't fill in the survey. So actually, this sample we have may be not a representative sample of the overall population of students taking the math exam, if this is the case. So basically what we did is we didn't use this data as the main source of our database, but we used administrative data. So simply we went to the offices of Ca' Foscari and asked for the official records of students. So just looking at, administrative data. Anyway, before going to the data that I will show you that was used in the econometric analysis, this data is anyway useful to get an idea of if students liked the page, they found it useful, and so on. But of course, beware that it might be an overestimate of the positive effect if just students who liked the page or liked math filled in the survey. Anyway, just a few questions. So one of the questions was, which kind of user are you? So as you can see, approximately 2/3 of students said they were not very active, meaning it was specified, they mainly read the content. So they were mainly reading what was going on the Facebook page. While 1/3 of them said they were fairly active, meaning not only they read the content, but also they wrote on the page sometime. Barely nobody said that they were one of the least or one of the most active. Another question was, how often did you visualize the page? And actually visualizations were quite frequent. So as you can see, 47% approximately of students said they visualized the page once a day. 26% said several times a day, and 23% a few times a week. So actually students seem to have visualized the page quite a lot. Okay, so going now to the quasi-experimental design. So as I told you, basically we take advantage in the main specification of the fact that several parallel math courses are taught for economic students of the same university, but in different branches of the university. Okay, to go into the details, since you are of Ca' Foscari, the experiment actually took place in Treviso, while let's say the control group are students taking the same math exam, but in Ca' Foscari, but in Venice, without the Facebook page. So basically, with another professor. Of course, this is an important assumption as well. I will try to convince you that in the specification we use, it doesn't make a difference, but of course it's a fundamental point as well. So we use a difference in difference approach. Basically what we do is we compare the average difference of math grades for students in the treated group with the average change in math grades for students in the control group. So as you can see, there is a before-after in our specification. So what is this before-after? We make here an important assumption, which is the following. We assume that if the Facebook page had a positive effect, it's just for students who followed the course and took the math exam within the January session of the year in which they followed the course. Why? Because it's unlikely to think that you followed the course in the first semester, then you take and pass the exam in June or in September, so 1 year, almost 1 year later, or even more. It's unlikely to think that you are still benefiting from something that you saw on the Facebook page several months before. Moreover, we basically monitored the activity on the Facebook page, and we saw that after the course finished, basically activity on the page drastically dropped. So students were writing on the page a lot during the course. After the course finishes, of course, we cannot exclude that some people visualize the page because we did not monitor what people are looking at, but we know at least that students did not write on it. Okay, so we make this assumption. Of course, stop me anytime if you have questions.
Yeah.
Yes?
Did you consider like video tutorial or audio, something like this on your page, on the page on your page, like the Facebook page? Did you consider adding like video or audio tutorial or only text chat?
Actually, it was just asking questions. Yes, so in the years after, there were some blended learning experiments with flipped lectures, so actually with the professor giving out some videos, studying at home and then going to solve exercises in class, but this year no. So it was just standard teaching in the class plus asking questions on the Facebook page, so no videos on the Facebook page. Okay, so the main specification of the analysis we start with is the following. So the dependent variable is grade, so it's the math grade obtained in the mathematics exam. And then we have basically two dummies. So the first dummy is January. It's a variable taking value 1 if you pass the exam within the January session, and 0 otherwise. We have another dummy, which is TI, which stands for treated, which are students who took the math exam in the treated town, so basically in Treviso, the ones who had availability of the Facebook page. And so the main point is the following. What we are interested in is the interaction term, so the January times Y. So what is this? Basically, this is identifying the subgroup of students who took and passed the exam in January and were in the town where the Facebook page was activated. So the coefficient we are interested in is this beta D, which is actually identifying, again, as I told you, the subgroup of students who were in Treviso and passed the exam in January. So, okay, so for example, if we look at the graph here, so T12 is what? Is average math grades of students who passed the exam in January in Treviso. C12 are average math grades of students who passed the exam within the January session but in Venice. And the same T34 and C34 are math grades of students in Treviso and in Venice that passed the exams in June and in September. So for example, why we cannot just take the difference between T12 and C12? So the simple first idea would be, okay, let's compare math grades of students in Treviso within the January session and math grades of students in Venice. Why we cannot do this? Going back, of course, to your claim, because perhaps it can be that the professor in Treviso is grading differently from the one in Venice. So I find a positive effect and I think, okay, I found a positive effect of Facebook, but it might be that it's not Facebook, but it's that Professor XY just tends to give higher marks.
Or it's much better than the other one.
Yeah. Yeah, or yeah, or yeah, or yeah, so it can be that he explains better and students understand everything, or he just explains very badly and gives high grades. We don't know. So the other thing we cannot do also is we cannot just compute the difference between math grades of students who take and pass the exam in January in Treviso, where the Facebook page was activated, minus grades of students who passed the exam in June and in September. So we assume the short-term effect. So we say, okay, in T34, the page has no effect. Why we cannot just take the difference between these two? Okay, the reason is because it is also shown very well in the literature and it comes out also in our data. The point is that students who tend to take and pass the exam right away are usually performing better. So they are the students who follow the course, study more, and tend to have different grades. So just taking this difference, again, we might find a positive effect, but it may be due to the fact that these are better students. So basically, what we do is we compute a double difference. So T12 minus C12, which is the first difference, minus the second difference, T34 minus C34, which allows us to net out the potential professor effect. So, of course, here we have to make an important assumption. I mean, what this assumption is called is parallel trend assumption. So we have to assume that if Professor A is grading in a certain way in the first session, he has to grade in the same way in the second session as well. So we might have a problem if one of the two professors is saying, okay, in the first session I tend to give slightly higher marks because students showed up right away, but he doesn't do this in the second appello session. So we have to assume this parallel trend assumption. So if there is a slight difference in grading methods of professors, it has to be the same in the first and in the in all the sessions. In this way, we are correctly to net out. We are correctly able to net out the potential biases. Okay, try to speed up, but okay, I think we're fine. So we have to make sure that the two courses are basically identical according to several dimensions. So in fact, the professors were different, but the courses had the same program, the same textbooks, the same number of face-to-face lectures, the same more or less availability of office hours, or at least formally, and even the exam is the same. So, okay, so from the point of view of comparing the courses, we should be fine. Moreover, we need to control, as we were saying before, that students in the two groups are similar. So we can try to use all the observable characteristics we have to convince ourselves that we are looking at similar samples, because of course this is again a fundamental point. So how do we do this? Okay, I hope it's not too small, but anyway, so we took observable characteristics of students in the two groups and tried to compare their ability, let's say. So how do we do it? We look, for example, at high school final mark of students in the two subgroups. So this is an ex-ante measure that can be used, let's say, as a proxy for student ability. So if we look at the table on the left, the first column is averages for students in the treated group, so Treviso. The second one is averages of students in the control group, so Venice. If we look, for example, at the third column, we see that they actually perform quite similarly in the grade they obtain in their high school. So the third column, for every variable, is the p-value of, okay, in this case, a Kolmogorov-Smirnov test comparing the distributions. We also did t-tests on the means, and the result is the same. So basically, high school final mark of students in the two groups is not statistically different. The same holds for GPA of students, so they do not have significantly different averages. And there is a slight difference in the standardized number of credits, so how many exams they pass. So standardized 0.52 against 0.56. So the difference is significant from a statistical point of view, but the magnitude is quite small. Of course, it's important to stress that grades in these two groups are not standardized. So professors are not grading with the bell curve, because it could be that there is a systematic difference in the performances of students. So, but they are, let's say, we cannot see them because the professor is grading with the bell curve. For example, in Treviso, they all perform very badly, but the professor is grading on the bell curve, so the distribution is shifted. We would see an average of 24 perhaps in both groups, but this could be actually meaning something different, which we don't see. But actually, this is not the case. Two other quick checks. Again, I mean, it's, as you can see, then once you see the analysis, it's just a table, but it's important to convince you that the two groups are similar. So it's really the fundamental thing to try to claim causality. So we did two other checks. One thing we did is we used this online portal called Eduscopio. It's a tool that's available on the internet that is basically used by students that want to choose to which high school to go to, according to which high school then prepares you better for university. So on this portal you select which kind of high school you want to go to, where you live, how far you are willing to travel, and it gives you basically a ranking of high schools that is done according to how well students that went to that high school perform in university. So it's basically telling you which is the best high school you should choose that better prepares you for university. So basically, to keep it short, we do not find a significant difference in the quality of the type of high schools in the two towns, because of course the 77 of before could look the same but could have different meanings, but it should not be the case. Moreover, last check we did before going finally to the regressions is we compared teaching evaluations of students in the two groups. So we are interested in checking if there is a significant difference in the quality and the satisfaction of teaching done by students in the two towns. So if you look, for example, at the right part of the table, so we look at an average measure of all teaching evaluations of the courses held in the two towns. So if you look at the 2 years in which the experiment took place, you can see that actually numbers are really very similar. So on a scale from 0 to 5, average satisfaction of the quality of teaching in T, so in Treviso and in Venice, is 3.22 against 3.25 on a scale from 1 to 5. And the same thing is for the previous year. So basically, to summarize, what this table is telling us is students are basically equally satisfied about the quality of teaching and about the courses in the two towns. Okay. Yes?
Just to understand, C is the control group.
So Venice, yes.
When is Venice control?
Yes.
Without any Facebook?
Without any Facebook.
And all means all the students?
All means all the courses, yes. Okay. All the courses. So yeah, they gave me from the administration a big table with all courses, satisfaction for each courses, and this is just the average. Okay. So an aggregate measure of satisfaction. Okay, briefly. Okay, try to speed up. Briefly about the data. So as I told you, we use two sources. One is administrative records, which is the main source, and the second one is the survey filled in by students. So from the administrative offices, we can get information on a bunch of things. So type of high school attended and final mark, demographic data such as sex and province of residence, and all of the university records. So year of enrollment, grade in the math exam, grade in all the other exams, and like this we can compute GPA and credits. Okay, so this is just a table with some summary statistics. So you have 4 cases because it's 1-1 means Treviso, so with the Facebook page, and passed the exam in January. 1-0 means Treviso and passed the exams in the following sessions, and so on. So 0 means control group, so Venice passed the exam right away, Venice passed the exam later on. So actually, if you compare numbers, you can see that it is exactly what we were expecting, both for math grades and GPA. So look, for example, at GPA, second part of the column, first number. Average is 24.13. So students in Treviso who pass the math exam right away gain on average 14 as their GPA, while students who pass the exam later on have a lower average. And this is true both in Venice and in Treviso. So, okay. Okay, so going finally to one of the first tables showing results. So we have different specifications here, but the important things to look at are the following. So again, just to summarize, T is the dummy for treated, so Treviso. January is the dummy for I passed the exam right away. The coefficient that is the important one is the one in bold, which hopefully you can see, which is January times T. So students, again, who take the exam and pass it, take the exam right away and pass the exam and are in Treviso. So the first specification actually, you see, we include in the regression only January T and the interaction term. So probably this regression has a problem, maybe an omitted variable bias, because we are not including any quality check for the students. So we repeat the same regression and go, for example, to look at the third column. So here what we add, basically we are adding some covariates. We're adding HSZ, bad labeling, anyway, high school mark. And we are adding also dummies for type of high school, because we realized it's not only important the grade that you obtain, but also the type of high school you attended is a significant variable. So in the third specification, we have, for example, that high school final mark is a positive predictor of grades. So if you got a higher grade at high school, you do perform better. And additional high school type is added as a covariate. And we have some additional controls. I will go into it right now. So, okay, what's the summary of the table? Looking, for example, at the third column, we see that students who, again, take the exam in Treviso and pass it right away, gain on average 0.849. So what does this mean? Students in the subsample we are interested in, so Treviso and pass the exam right away, gain on average 0.85. So approximately 1 additional point. Okay, it's not much, but it's also, I think, a reasonable, it's statistically significant, and I think it's a reasonable number. Actually, it's unlikely to think that if you don't study, you go on Facebook, you pass the exam. Or, I mean, if you are a good student, of course, you pass the exam and you do not need Facebook. So, I mean, I don't think that Facebook can make a huge difference, but perhaps a small one and significant, yes. So it seems to be of a reasonable magnitude, let's say. Other maybe interesting things to notice are the following. So January, the coefficient for January is 0.85 and it's statistically significant. So meaning students who take the exam in January, given the other covariates, so regardless they are in Venice or in Treviso, they do perform better because they get statistically 0.85 more. While the dummy for T, which means treated students, in this specification is not statistically significant, which is good. What does this mean? Given the other covariates, it doesn't matter if you take the exam in Venice or in Treviso, netting out the other covariates. In the fourth column, compared to the third, basically we add some dummies. So we add course fixed effects and time fixed effects. So what is this? Course fixed effects is this. So in Venice, so in Treviso you had just commercio estero. In Venice you have different tracks. So you have, I don't know, consulenza aziendale, whatever, marketing, economia commercio, economics and finance. So it might be that these students are slightly different according to their math abilities. Perhaps students of economics and finance are better in math compared to students taking marketing, perhaps. So basically what we are doing is we are adding, to take this into account, we're adding dummies to control for this. And again, the result pretty much does not change, as the coefficient of the interaction term is still statistically significant, and then the value is 0.71. So there is something strange going on. You might be asking yourself, what is that minus 2.59, which is statistically significant? Actually, it's just because adding the course fixed effects, there is also one identifying the subgroup of students taking commercio estero. So actually it's not shown, but there is another dummy which is identifying the same subgroup and they interact. So actually there is a multicollinearity problem, so it actually should be dropped. So there is a coefficient with exactly the same magnitude and opposite sign, but the message is pretty much the same. Okay, so this is pretty much it. Then I have done something else. So I have another set of regressions which are exactly the same, which are probably wrong from a statistical point of view, so I probably should not be showing them, but I will do it anyway. If you have time. No, then I also have something else, but okay. So what is this? Basically, we did exactly the same set of regressions, but not using as treated students data retrieved from the administrative records, but just a subgroup of students who filled in the survey. So we know who they are because we have their matricola, we have their ID, so we can repeat exactly the same set of regressions using as treated not all students, so not retrieving their data from administrative records, but including only the ones who filled in the survey. Okay, so maybe you can tell me if I think it's not correct, but you understood why, because these are self-selected, so these are students who chose to fill in the survey. And we are comparing them with the overall sample of students who took the exam in Venice. But they anyway seem kind of nice because, as you can see, if we look at the last column, or okay, the story is exactly the same again, we can see that the magnitude of the coefficient is higher. So I'm looking at the 1.47. So students who filled in the survey, if we look at the ones who passed the exam in January in the town where the Facebook page was activated, they actually do perform better than the overall sample. Why? Because of course in this sample we take data from administrative records. So who passed the exam in January in this year? We are correctly including students who followed the course, perhaps used the Facebook page and benefited from it. But we're also including maybe some students enrolled in the previous years who didn't follow the course, didn't use the Facebook page. So actually this is why I call it the effect of availability of the Facebook page. So it's an average measure including everybody who potentially benefited from the page. So if we look at only the ones who filled out the survey, the coefficient increases. And then we did again something else, so again a smaller subsample, which is students who filled in the survey and said in the questions that they were fairly active. So for treated students here, we include only students who filled in the survey and said that they were fairly active. In this case, the coefficient increases even more, up to 1.78. So it seems to make sense, but again, this is not probably a representative sample of the population of all students taking the course. How much time? 10 minutes? Okay, so maybe we have time for, sorry, something else. So what I did is the following. I tried to understand, here we are looking just at the treated students, so just the students who were in Treviso and filled in the survey. How many do we have? So we have 102 from the 2011 wave and 134 from the second wave. So a total of 236 observations. Actually, so in the first year, in 2011, the survey was given out, and giving your ID was voluntary. So if you wanted, you put your ID. If you didn't want, you didn't. Then the second year, he realized, okay, if we want to do an econometric analysis, we cannot do anything with the data for which we don't have the ID, because we can just look at answers in the survey, but we don't know their math grade, and we do not know anything about their administrative records. So in 2011, we just used the subset of students who gave us ID. So potentially this is not a representative sample. What we can do is we can simply check observable characteristics of these students. So observable, of course we cannot check unobservable ones, so how much you like Facebook we cannot check, but we can check observable characteristics of these students compared to who? The overall sample of students enrolled in Commercio Estero since 2009. So what we did is, again, the same check. We compared high school final mark, GPA and credits, and we find that, again, there is not a statistically significant difference in observable characteristics of these guys compared to all of the students enrolled in this track. So, okay, I mean, it seems to be a reasonably fine sample to use, even if they are not a randomized sample of overall students enrolled in this course of this track. Okay, what we did here is we estimate a probit model. So here the dependent variable is 1 if you passed the math exam within the January session, and 0 if you did not pass. What we want to estimate is the effect on the probability of passing. Of what? Again, bad labeling, but this is answering the question, how frequently do you visualize the page? So the first is high school final mark as a control. Then you have few times a week, once a day, and several times a day. So what you can see here is basically the following. So the more you visualize the page, higher is the probability that you pass the math exam, controlling for high school final mark and type of high school. In the right column, it's just adding additional covariates. So actually it's a probit model, so we look at the marginal effects, and we see that increasing the probability, visualizing the page few times a week, once a day, and several times per day, increases the probability of passing the math exam by 20, 24, and 28% in the case with additional covariates. The story is more or less the same without. We did also other, we tried the same thing with other models, but basically the result is the same. So we tried the logit model and the linear probability model, but the results are pretty much identical. So this result seems to be robust. Last thing, so last regression we did is the following. So again, we try somehow to take advantage of the different questions in the survey. So here the dependent variable is again grade, so it's not a probit model, it's simply OLS, where we have as covariates activity, so it's the answer to the question, how active were you? Fairly active, not very active. And different measures of ability. So if we go to the, maybe this is small, but okay, I will try to tell you what this is. So if we look at the outcome of this set of regressions, we can see that, okay, activity is not statistically significant. So this is a dummy saying 1 if you read and write on the page, while 0 if you mainly read the page. So reading and writing is not significantly better than just reading what was on the page. Again, controlling for GPA, so grade point average in this case, and another set of covariates. So what maybe interesting here is the variable useful 10. So what is this? Basically, this is the answer to the question, how useful was the page for you? So students had to give an answer from 1 to 10. So actually, over 50% of students answered the 10. So they thought the page was very useful. Were they right, were they wrong? Let's see. So what we did is we built a dummy variable which was equal to 1 for students who said that it was useful 10, and 0 in all the other cases. So what you see here is that the estimate for this variable, it's the useful 10, so the effect is positive and statistically significant, and the coefficient is equal to 1. So this can be interpreted in the following way. So students who thought that the page was very useful actually gained 1 additional point, and the difference is statistically significant. So basically, students kind of were correctly able to judge if the page was useful for them or not. So there are some students perhaps who don't like Facebook, don't have a smartphone, they want to study just with paper and pen, and for them the Facebook page is not useful, while perhaps there are other students who are always using the smartphone on the train and so on, and actually they realize that the page is more useful for them, and actually it is. Actually there is, then I'm done, there is also another set of regressions which I'm not showing you. There is also a question which is, tell me how many points do you think you would get thanks to the Facebook page? And actually a lot of students said, for example, over 2 points, but then it's not statistically significant. So what does it mean? Maybe students were excited about the page and they thought it would help them a lot, so they said, okay, I think I'm gonna get more than 2 points, but then actually it's not statistically significant, meaning some of them overstated the usefulness of the page. Okay, 1 minute. Okay, not really important. So what we did is here different specifications, so simple OLS, but the story is really robust across different specifications. So we did a Tobit model. Why? To take into account that the dependent variable is bounded with between 18 and 30, but the results do not really change. Last thing I want to show you, really the last one, is we did the last set of regressions where basically here we are using just the students who passed the exam. So we might have a bias because we are not including students who did not pass the exam. So what we did is an Eichmann selection model where in the first stage we estimated the probability of passing the math exam using credits. We also used the grades of statistics as another trial because it was a first year course and it's maybe similar to math. But anyway, the result does not change. So what we did is we estimated first the probability of passing the math exam, and then we included these probabilities in the outcome equation, so in the second step of the Eichmann selection model, and I just added the results to the fourth column. But basically, nothing changes, as you can see. Activity is not significant, while useful 10 is. Okay, this is pretty much it. Maybe I'm out of time, so I don't even need to summarize results. Just one thing, I mean, of course, this seems to be a useful tool, but okay, so on the other hand, there are of course some drawbacks. One of them, just a side information, of course, it's super time consuming for the professor. So he had to follow all the posts. Of course, you do not want wrong information also to spread, so you need to kind of check that students are sharing correct information. So this experiment was done for 2 years, and then, okay, it was not done anymore, but other useful experiments such as blended learning and so on are going on and perhaps are useful to improve education. Thank you.
Thank you very much.